I'm Hanan, so I'm the project manager on the Tonsley Technical College and Factory of the Future project. Today we'll just be talking about mass timber construction from a builder and contractor perspective, so I won't get too technical about the design or detailing. A bit of a project overview. So this is a combined project for Flinders Uni, Factory of the Future and Department for Education, Tonsley Technical College, which will teach construction, manufacturing, defence in loading spaces that mimic real life workplaces. This project's approximately $50 million in value. We were involved pretty early in concept design and designed by our studio got never on there. That's part of the project. We're targeting 5-star Greenstar and a World Core Gold rating. And most importantly, what I want to talk about is the mass timber. So it's the first mass timber project in SA to utilise CLT and GLT timber. So just a bit of background, I'll use a lot of abbreviations. GLT is what we're talking about, glue laminated timber, which we used for columns, beams, trusses. All of those were sourced from a company called Ash in Victoria, with the timber itself being from Tasmania. And then our slabs are CLT, so they're cross-laminated timber, which is essentially the same in layers. And we use that for the slab, so it's a 4,000 square metre footprint. We used it for the level 1 slab and the roof slab. And all of that came from the facility that was mentioned earlier, the Mount Gambier facility for Timberlink Next Timber. So all of our timber on this project is Australian sourced and fabricated. Just because it is mass timber doesn't mean we didn't use any other structural material. We still had precast concrete for the cores, ground floor concrete slab and structural steel, which you can see in the picture. There was about 110 tonne of steel still used, and all the connections between the timber to the other structural elements as well. So we got involved very early on in the concept design with the design team. We took on a design management role and sort of saw that process through 60% design, 90%, and then through to construction. There's a bit of a different mindset when doing mass timber projects. It has to be very front-loaded, so you can't sort of start on site and then work it out as you go. There's quite a lengthy process up front, so we had about 7 or 8 months in the lead up to being on site. Our previous experience was more with modular off-site fabrication. I did a project which was timber panelised, but this is obviously our first because it's an SA first doing mass timber. The reason for using timber on this project was largely client driven, so from Flinders initially and then Department for Education, but the main reason was program benefits. So we had a very tight program that we needed to meet and timber was the only way to achieve that. Just a few challenges, misconceptions that sort of come up when you're dealing with timber. Obviously, multiple stakeholders just sort of made the process challenging throughout. We spent a lot of time in design, certification, consultation with the MFS, and then it sort of goes around in circles till you get to a point where everyone's happy. Cost comparisons with steel and concrete tend to come up all the time. Everyone wants to know how they compare cost-wise. We did that analysis early on in the project, but when you're sort of starting out, cost-wise, it is more expensive up front, but then when you start to factor in the program benefits down the track, it sort of equates to about the same by the end of the project. Like I mentioned before, it's very heavy front-end work, so all the coordination's got to be done very early, and engagement with the suppliers as well. The suppliers themselves, they're great to work with, which I'll talk about in a second, but because it's still a relatively new industry, there's a lot of off-site payments that need to be accounted for, and you're essentially paying for a lot of the timber before it even hits the site, which is a bit of an unusual process with construction. So we started off by locking in the GLT supplier, which was Ash. Their production timeframe and when they could slot us in essentially dictated the rest of the program. Then we locked in a CLT supplier and Timberlink, and then we immediately needed to lock in a timber installer. We used an in-state mass timber installer on this one, and essentially those three are what inform costs. So to finalise tender, they inform connection details with the engineers, and they also inform program. So it all comes from engaging those. The program and scheduling. So like I mentioned before, we locked in the program. Something that we sort of didn't account for is, yes, you lock in the timber early, but to actually get that whole documentation process done, you needed to lock in other structural trades, services trades very early on as well. So all the coordination could be done. With all of that, it sort of lent itself to a stage tender model. So we had stage tender, stage construction, where we sort of lock away structure services, then do facade, then do fit out. Sorry, I talk a lot with my hands. Moisture management and builders work. So this one's one that comes up all the time when you're talking about mass timber. People want to know how you protect it. It starts with offsite, so all the timber comes out. If it's CLT slabs, all the edges are sealed. There's no raw edges. The columns and beams all came pre-coated with one coat, and then the ends had protection on them as well. And then when they're stored offsite, they're stored undercover in factories with suppliers. During transport, it's all wrapped in plastic, delivered to site, and then stays that way until it's installed. Storage on site, it's just making sure it's not sitting in pools of water, and we essentially were constantly manually dewatering. So we had a big tennis court squeegee which we dragged along the slabs anytime it rained. And then even with that, there were still some areas that if they sat out in the rain too long would get local mould, which gets treated during construction. So it's all pretty manageable. Post-construction, obviously, we've then got to keep that up throughout the build until we close it in. So we've recoated the timber. Most of it is internal. There's only a few areas that are external, which will have additional coats, and then the maintenance procedure gets passed on to the client that they have to keep up. It's pretty basic, so just sort of touch-ups every year. So then general outcomes of the timber program, which I mentioned before. So overall, it was about 10 weeks quicker compared to traditional structure for this build. We had almost 670,000 kilos of carbon captured just from the timber structure. That contributed to most of the 20% reduction on emission for our Greenstar points, for the upfront carbon emissions, and then also the life cycle impact points and responsible structure. And then we had pretty minimal waste from the structure, both offsite and onsite, because it's all made to digital models. Probably one thing that I just want to mention that it's not really a tangible outcome, but working on a project that's a mass timber project just feels different to any other construction site I've ever been on. The biophilic design is the technical term, but it just generally makes you feel better working around timber. All of our contractors seem to take more care, and pretty much the way it's arrived to the way it is now still looks exactly the same nearing completion. Thanks.